think it started. All right, welcome everyone for the September version of Loki Community Call. Uh, I hope everyone has the access to the doc. Who are people are here? Let me also share it in the slide. Sorry. I think before jumping into the call, we also changed this time. Usually it happens in the US time zone, and we changed it to like 12 UTC, so that you or APAC folks can join. I think maybe let's jump into the agenda. Before that, anyone wants to add anything? All right. So I see the first in the agenda is Loki will analyze the demo by Vlad. Vlad, do you wanna take it up from here?
Yeah, but I need to join. Give me a second.
Yeah, no worries. Meanwhile, we can also discuss the second in the agenda while Vlad is setting up. So I don't know who added this one. Maybe Jen, I don't know.
Yeah, I think
Which one,
Jen
sorry?
the one from us.
Yeah. I mean, I think this was I was the facilitator, but I don't have any specific feedback. I asked the folks who filed the proposal to come, and thought we could chat with the rest of the Loki team.
All right, no worries.
Okay, so now we can start. Yeah, and we are happy to announce that we released Loki Analyzer, and you can find it on Loki Docs in LokiL section, and here we have Loki Analyzer. This tool might help you to develop your own query to solve some specific issues, and you can use it if you want to play with LokiL against some specific log lines. So, for example, here we have some predefined examples like log FMT, JSON, or structured text with pattern parser. And here you can see that we can define log lines, our own log lines, and we can define our query, and we can see the result actually. And the main difference with Grafana Explore page is that here we also have the results that are filtered out. And you can check on each line, you can see all stages that were executed with this line, and you can see how the log line was transformed on each stage, not on this one, or also you can see on which stage this line was filtered out. And for example, for this line, we can see that after this stage, after stage line format, we transformed our log line to this, and previously it was just a JSON. And also on this line, when we apply JSON parser, we can see which labels were extracted with which values and so on. So it might give you some insight how actually the query was executed. Yeah, and also it's pretty useful when you want to help somebody with some local expression. You can create or modify your local query. For example, we can change it to this in this way, and we want to share it with somebody else. We can just give him this URL, and when he opens this URL, he will see your query and your log lines. Yeah, but here we have some limitations that this URL cannot be. We have length limitation to this URL, so you cannot provide. You cannot share examples with a long list of lines and this super huge query. So it's just a limitation for now. Yeah, but in general it works, and yeah, I found it pretty useful for me. Yeah, and if you have any suggestion or any improvements that you can do, you can do it using this link to edit this page, and you can just edit it if you want, or you can just suggest changes to this tool. Yeah. Do you have any questions?
Yeah, go for it, Simon.
Yeah, I'm just wondering, this looks really, really cool, very useful. Does this analyzer also include any Grafana specific functions, or is it just pure the pure logql?
Yeah, just pure logql, and also we have one limitation here that you cannot change string selector. So here we have predefined selector with value job analyze. You cannot change it. So you can just play with logql functions and with attributes and just with query. And also you cannot use here metric queries, because we don't have here actually timestamp. So we don't know about this timestamps, and we don't have functionality to somehow assign this timestamp to this log line. Yeah, it's just for now, it's just initial version. Yeah.
Thanks. I have one question though. Can this be like shared, like as a short link or something? I see the share button there.
Yeah.
So we can use it as a discussion or in the issue or something, right? And should be possible.
Do you mean to create a short shareable link?
I mean, it doesn't have to be short per se, but all I want is like if I use this for some specific log lines and specific logql, I should be able to share it with someone, and they come to the same page. They should be able to see the same logs and the same.
Yeah. For example, we can delete some lines and click share button, and the URL will be copied to clipboard. And if we open this link, you will see exactly these log lines.
Yeah. Okay.
So the state will be shared with somebody else.
Yeah. Great.
I think. Thanks. Next.
So that was actually the part I wanted. This is kind of my favorite part of this. So you can replace the text that's in there and the query, all of that stuff, and click the share link. And so you can essentially create a specific example for someone. If someone's trying to solve a use case around logql, you can insert their log line and the query and share that. And the link embeds all that information. So I'm sure there's some limit to the amount of log lines you can put in there, because it all becomes query parameters, I believe. But I think that's going to be super helpful.
Yeah, and also one thing that I want to mention, that with the next version, for example, when Loki 2.7 will be released, we will also release logql analyzer API server with the same version. So as long as we have versioned documentation pages, we also have versioned API server for this analyzer. So this documentation version is compatible with Loki 2.6, and in the same way, it's compatible with logql analyzer API server 2.6. Yeah, so once we release 2.7, we will release also documentation 2.7, and also will release logql analyzer API server 2.7, and it will understand all new functions if we add any to 2.7. So it's version API. Yeah. And also maybe it's important thing that I forgot to mention, that to run this query against these log lines, we use API server. So we send requests, and analyzer produce this debug information for us at returns, and we just display it. Yeah. But this API server doesn't store any information and just receive log lines and query as request parameters, process it, and return the results back.
Nice. Thanks, Vlad. Anyone have any questions before we move on to the next item on the agenda? All right. So let's move on to the next one, which is the proposal from the community. So
yeah, so Kavi, maybe we could start. I know we have a couple of folks on the call. The folks who filed the original proposal, maybe just walk us through like why, like what the use case is for y'all, and then maybe what are any outstanding questions you have left on your proposed implementation.
Sure. Ryan and Jose, do you want to take this?
Sure. Jose wrote the proposal, so I guess I could let him lead it and fill in any gaps.
Sorry,
I can't hear you, Jose. I see you talking, but I can't hear you.
Okay, well,
now it's better.
Now. Awesome.
Wonderful. So, my name is Jose. I'm with Simon and Ryan. We are part of the observability team at Canonical, and we are writing a Loki operator that is called a charm that deploys and manages all the entire life cycle of Loki. And one issue we found is the following, that when we deploy Loki, not using an object-based storage, we may accidentally fill the available space in the PVC. If that happens, Loki will crash. We were looking for alternatives to solve this. We also saw that there were some requests from members of the community to add a way to specify in Loki, okay, you need to start deleting chunks when the space reach, for instance, I don't know, 80% of the available space. And also we saw that there are some hacks the community is doing in order to solve that. That is, well, we can put a cron job that runs and script every 10 minutes, for instance, and delete the chunks. And after that, you have to rebuild the indices. So this is, from our point of view, this is not a clear answer to this issue. So we start thinking about, okay, what's happened if we try to include this functionality in Loki? That's why we were thinking about in this possibility and start discussing in the Loki community Slack with the other members, and created the issue with our proposal. Obviously, our proposal it's just the surface, because we can read the Loki code base and modify it and share the solution with the community. But yes, we may need your assistance, maybe trying to find out if our proposal is good enough. What do you think about it? What do you think could be the best approach to tackle this issue? Yes, I think it's a good introduction. I don't know, Sima or Ryan, if you would like to add some more aspects of our proposal.
Sure. I guess many of you might already have seen the issue and had a look at the proposal. But the idea is that we would use the same or similar facilities that already exist to do the time-based retention, and try to deduce what point in time we need to delete up to fit within the space requirements, and then use a time-based delete just as we would in the existing retention functionality to do that. And I kind of get why this hasn't been prioritized, or why it's not part of Loki. I mean, if you have an S3 storage, you don't really care about the fill up in that sense. You probably rather say, I want 7 days or 14 days, and that's it. It makes perfect sense when you're on a cloud provider. In our use case, the whole point is for people to run this in their own managed infrastructure, and then you don't always have that privilege. Hence why we think it's useful to have it in the product.
I think, to be very explicit, the issues on the tracker have been open for quite a while, and while using block-based storage is potentially a smaller use case, we are trying to strike a balance between, we do not want to directly read the file system and worry about whether there are sparse files or what the PVC actually looks like, or potentially corrupting indexes as the cron jobs seem to. So instead, if we take a relatively simple use case of, if you're running on block storage, then you can set a percentage option. And if it is set, then we can go through and start another timer when Loki starts, which will affect the percentages, scattering whatever file system the chunk storage is on it, which will hopefully make it maintainable enough that if they change to TSDB, change the on disk format, we don't really care. Then to use the same functions that Loki calls internally from the timer to invoke the deletion itself, rather than trying to go, behind Loki's back and directly touch chunks or blocks or inodes. And I think that the goal partly is to solve a community need while also keeping it simple enough that it doesn't add a dramatic maintenance burden to the Loki maintainers or a huge new set of use cases, which frankly would be better served by Object Store. And that is what Grafana Labs makes money on anyway.
Absolutely.
I would say that
sorry.
very welcome. Sorry, Cindy. But, the usage stats that we added in 2.6, something like 75% of the Lokis that are reporting back to us all run on a file system store. I think most of the community users just run a relatively simple single binary and back it with disk, and that everybody that's doing that would appreciate having a bounds on how much disk that can use. There have been issues open for a long time on this, but you're right. I mean, just for us and kind of how we prioritize work and what we built, it's never been enough to sort of, make the top of the list, but it's awesome that you're all able to take a look at this. We can do everything we can to help get you moving forward on it. I really appreciate
we just wanted to make sure
help.
prior to committing any significant effort to it, that it's a direction you want to go in, and that we're not writing something that would end up in a fork somewhere regardless, right? So hence why we're here.
Yeah, no, absolutely. I definitely, at least, I don't speak for everybody on the team, but I would, unless anybody here has opinions, not like I mean, most of the team is here. So I think this would be a big help for anybody, operationally speaking, using Loki on storage that, specifically file system store. There's a lot of users for that, but nope, I would love to merge this. This would be great.
I think that for me, in the end, the devil is a little bit in the details, and we're happy to have an ongoing discussion on the PR. But when we get closer, there is a question of what if some out of control service starts sending a ridiculous amount of logs every second? At what point do we stop deleting logs which may be valid and send a warning and terminate Loki or something else in order to protect production data? And that is a trade-off where we will probably want input from product or the rest of the community leaders.
Yeah, it's interesting. I think we could handle that the other way up front too with rate limits. So if you have rate limits set to like how much data a cluster can receive, that effectively limits how fast you can delete it, as a consideration too. But yeah, right. Like if somebody wakes up in the morning and the only thing they have logs of is one service, that might be a bad experience.
And I think since we have Sandeep on here, maybe you wanted to say, Sandeep, it seemed like when I was reading through the proposal, the main thing that there was maybe some back and forth on is, do I use the delete APIs or do I use some of the other like inbuilt cleanup functionality? It seems like the proposal's gotten aligned on that. Did you want to check? You're the last person to chime in, Sandeep.
Yeah, so like I didn't prefer delete API because it's hard to know how much data, like what range you want to delete the data. You would anyways have to iterate to the index to find out what the oldest chunks you have. So it's better to iterate to the index and delete the chunks then and there, because delete APIs would delete the chunks after 2 hours by default. So you need to either tune that config again to delete the chunks instantly, which is why I prefer not using delete API and have a separate code path for uh, reducing the usage based on how much disk you're using.
Yeah,
I
that's
think my
totally fine with us as well. I mean, the only reason why we even considered the delete API is because we wanted to give you as little to maintain as possible. But if you're saying that it's preferable to do it the other way, then we'll definitely do that.
Yeah, there's a lot of code that you can reuse even while iterating through the index. Like there are iterators available, and you can use the API object store API directly to delete the chunks immediately.
I wondered from a technical point of view, right? One of the things we saw in the older issue.
Sorry?
That could have, let's say, if chunks were directly deleted without, with the cron job or something else, that it'd be possible to have log QL queries with labels that actually had no records attached to them. And I understand that you think delete API would have to wait 2 hours, but I also wonder if we're submitting a PR, wouldn't we just be able to invoke the functions which delete things immediately?
Oh, you're thinking that we're using the delete API and then manually trigger a cleanup directly afterwards. Is that what you're saying?
Yeah, that is what I was saying. If we're inside the code base, can't we just invoke the function immediately after instead of waiting for the timer?
It would be hard to tell which chunks were deleted due to retention or which chunks were deleted for reducing the space.
Oh, yeah.
So like
certainly.
effectively, like you are not honoring the config for returning chunks for few hours.
Yeah, no, that is certainly true. And I haven't read the code base in depth, but it looked like going through that it would mark them and then another job went through. So if we invoke the function which deletes all of the marked chunks, then we would keep coherency between the table and the chunks. We don't have to, like, maybe there's a very good technical reason not to do this, but it certainly appears
Sandeep said, right, Ryan, in that case, we would also delete everything else that's marked for deletion, which would be inconsistent with what cleanup interval they've set in the config.
So like thinking more about it, why we have that config is because we want to let the index, updated index get propagated everywhere. Like because if the index is cached and your chunks are not there, then the queries would fail because it would try to download the chunks that are not existent. So probably my approach would like make this issue visible to the user, but like let's take it on the issue, and I'll think more about it, what we can do. But yeah, like 2 hours of delayed for returning the disk space would be like might kill the Loki because it doesn't have enough space to write.
And wouldn't it also be more efficient to not go through the delete API? Because when going through the delete API, you kind of need to mark it as deleted first and then delete it. So you kind of need to iterate through the index and the chunks twice. Instead of if you have a direct access as part of a compactor, which kind of run to clean up the disk, you can just delete the index into chunks directly. I mean, we are talking about local file systems. We don't have the problem about propagating the updated index through to other ingesters in a way that we have in a multi-node setup. So I don't think that we have this problem with the caching and the redistribution of the index.
Yeah.
But still, in terms of performance and efficiency, I think having a separate cleanup component in the compactor, which is explicitly running just for cleaning up chunks and indexes, is yeah. I would recommend that.
Probably efficiency won't be a problem here because deletes are inefficient when you're using content-based delete. So here it won't be content-based. It would just go through the chunks and keep deleting it. But
Yeah.
like as I said, it's hard to find out what range you want to use for deletion.
Yeah.
But that's a good point that you're making, Christian. In that I think we jointly decided that we wanted this to only be something for a single node setup, right? That if you want to run it in microservice mode and kind of split things out, then we'll probably just write a warning to the logs and ignore the settings or something similar.
Yeah, I think I was going to say what Danny said, maybe just since we have a couple other options, I think hopefully at least this, I just unblocked this, hopefully some, and it was great. I think appreciate the Canonical folks for jumping on the call, and it's great to get to put some faces to some GitHub handles. And hopefully we kind of have enough that you all can get started at least on what an initial implementation maybe could look like, and we can keep going back and forth async.
For sure. Thank you for inviting us to talk about it.
Thank you for you, Jen, folks.
Yeah.
All right. Thanks, folks. Yeah, I think let's move on to the next item then. I think it's from Salva, operational guide. Do you want to take it over, Salva?
Yeah, sure. Hi, everyone. This is Salva. So yeah, I will be speaking about the operational guide we have put together about autoscaling queries. So as you may know already, the workload in the read path of Loki typically evolves through the day, right? So you may end up being either over provisioning queries, therefore paying for resources you don't use, or having to manually scale up and down queries. So to mitigate that, we started using Keda to autoscale queries. For those who don't know about Keda, in a nutshell, is a solution for Kubernetes that allows you to autoscale based on different events and metrics from different sources, such as Prometheus. So in the case of queries for autoscaling, we look at a metric that exposes in-flight requests, which are the number of queries that are queued in the scheduler and running in the query workers. This has helped us to reduce costs and operational toil quite a bit. So if you're interested, we have put together an operational guide to help you set it up on your own cluster. Okay, yeah, I was about to share my screen, but if Gabi is doing that, that's great. So as of today, the guide lives in the next version of the Loki documentation under the operations section. And this guide contains recommendations about which metric to use for autoscaling and how to tune it, how to estimate the minimum and maximum number of query replicas that the next section cap. And at the bottom, there are some alerting rules to let you know when you may want to consider increasing the maximum number of replicas. And very much in general, how to configure Keda to auto-scale queries. And yeah, that's pretty much it. I just wanted to raise awareness in case someone might be interested on doing that, and hope you find it useful. Other than that, we will soon publish a blog post about how we are using Keda internally and the challenges that we faced while configuring this internally. So stay tuned. And as always, we would love to hear feedback from the community and answer any question that you may have. So yeah, that's all from my side. Thank you. And if you have any question, feel free to reach out.
Cool. Thanks, Alvan. Before moving on, do anyone have any questions about data scaling? All right, cool. So the next one is on about TSDB. Sandeep, do you wanna take care of it?
So Owen has talked about like us working on adding support for TSDB as index store in Loki in the last community call. So I'll just add a follow-up, like to touch base on why we are doing it. Loki is a high intensity time series database, but instead of numbers, we store logs. So what would be a better alternative than TSDB, which is highly optimized and compact index store, which is built for indexing time series data. So we are internally testing it, and it is running as one of a replication of our largest internal deployment, which is doing 250 Mbps of ingestion and about 600 queries per second. Like most of those queries are coming from Loki Canary, plus it monitors all our internal clusters, so manual queries get added to them as well. So our focus right now is doing improving the stability and reliability of TSDB, and the implementation is not the vanilla TSDB that comes in Prometheus. We have forked the code and added some additional features to it. To like the biggest example is we are tracking how much data we are storing in each chunk. So this helps us predict how much data a query would touch, and this helps us optimize the queries as well. Like it would dynamically shard the queries based on how much data it would be touching. And the internal test results are looking promising. We are doing we are seeing 40% drop in overall CPU usage across all the services, overall, not in each service. And the index size is 50% smaller compared to BoldDB shipper index size with the same index. And because there's a drop in CPU usage, we have more headroom in processing the query. So we are seeing close to 4x speed up in some of the intensive queries. So we'll publish more details in docs and blogs soon when we are getting more close to making it production ready, or like releasing it in beta. Uh, this is still highly experimental, and if you want, you can try it and share your feedback with us. But it's suggested to not use in production yet, because it's still highly experimental. Yeah, Kavi.
Yeah, thanks, Sandeep. So is there any like a doc, at least to try it experimentally from the community?
Not
like
yet.
a quick start guide or anything? Okay.
Under the hood, it's same as BoldDB shipper. Instead of BoldDB files, we store TSDB. So the config is the same. Just use TSDB as index type instead of BoldDB shipper. Like I'll update the config at least. Documentation of the config at least, and like share it in the community Slack to call people for trying it.
Yeah, that will be great actually. So some like a quick way to try this experimental feature would be great. Thanks.
Yeah.
Sandeep.
I think that I do have something that Owen made that we can share here. Also wanted to share something I was looking at this morning. Yeah, this link in here. So this is kind of neat. So we haven't really had a chance to. Is my screen sharing? I'll take that as a yes. So we haven't really had a chance to see what the sort of upper stream limit is. So for the BoltDB index, we largely sort of an active stream limit of maybe 100 to 200,000, which combined with the idle timeout that we run is 1 hour, will let you put between like 1 and maybe 2 million streams per day. And then in a BoltDB index, we do a 24-hour table period on the index. So all of the streams for 24-hour period go into one index file, and that gets uploaded, and we keep one per day. And that sort of upper limit sort of looks like this graph here, kind of relates to this graph here. So this is our ops cluster that we mentioned, and this is the last 30 days of the CPU usage by the queryers. So this cluster gets a lot of traffic from the Loki canaries that we run, and there's probably 1,000 of them that are running against this cluster now. There's a lot of them, and so they kind of call out a worst case query for BoltDB where one of the queries they run sort of forces a 24-hour table scan. So that's why you kind of see this ramping effect where as the number of streams in the index gets bigger over a 24-hour period, the amount of CPU required increases. And as a result, the query latency might increase. So that's, kind of why we limit, you could put more rows in BoltDB, right? You could put more data in BoltDB, but you're going to be kind of fighting this battle. And so there's some big spikes here too. So let me figure out how to make it not show. There we go. So the red and blue line here are the 24-hour stream count for both of these clusters. So one of these clusters is running TSDB and one of them is running BoltDB. And I'm not sure why the stream counts aren't exactly the same, but they're generally close. But in periods where the stream counts are lower, that, ramping effect is less noticeable. And then as the stream counts get closer to like 2 million, this correlates roughly well. So here we're in the 2+ million in 24 hours, and you can see that the churn or the sort of increasing CPU requirements on the queries goes up. So what's exciting here is this yellow line. So this is the TSDB cluster, and the query performance is much more consistent. The spikes, they're not surprising there. So that's likely just, query load that this cluster sees as a result of humans using it too. So the canaries are a pretty consistently flat source of query load, which is the flat part of that line. And then, you see spikes on top of the green line too. That's likely people using the cluster. But so what's really exciting here is it, seems to all but eliminate that 24-hour time-based performance penalty. And this is kind of, expected because we don't have to do like full row scans, which is what happens. BoltDB is a NoSQL, key value store. And like I said, the canaries are the worst at this with the query they run, but it ends up doing a full row scan, which requires a bunch of CPU. So this is a big reason why we wanted to replace one of many, I guess, the index type is to have something more purpose built, but also to be able to push the number of streams in a 24-hour period higher, and not kind of see this behavior that we're seeing. So anyway, signs right now look good that this is doing exactly what we hoped it would. So I just wanted to share that because I just looked at that this morning. It was exciting. That's it.
Great.
That's all I got.
Thanks, Sandeep. So that's awesome. Anybody have any questions about TSDB? All right. So yeah, then we can move on to the next one before the open mic. So Yeah, from Carson, Helm shots for Loki. Do you want to take it up, Carson?
Yeah, sure. Me and most predominantly Trevor, who's not here today, have been unifying the Helm charts, and specifically for if you want to launch a single binary version or the scalable version. And we moved them back into the local repo. For one, to make it easier to test and make it more visible. And this will be the go-to Helm chart you should be using if you want to host Loki on your own, and it will default to the scalable version. And then it's all on main now. The next step are really testing. Trevor's testing the migration from the old Helm charts to the new one, and then ramping up the docs and make it a little more easier to use, so you get more like an out-of-the-box experience without modifying too many things. Kari.
Yeah. Is there any is it already added to the getting started guide or anything, Kashin, so that people can try? Or
we didn't release it, so if you want to try it, you have to go into basically the Helm folder under operations, Helm, and then the Loki chart and apply it yourself. We're gonna unify this as well, like the release process, to release with Loki together. So there's an outstanding PR, and yeah, it should just be a nicer experience and simpler. Because like I myself looked at 4 Helm charts and didn't know which one to pick, and now you get one pick. Christian.
So the Helm repo URL didn't change, right? So you can seamlessly update from
Yes. So thanks. So we changed the GitHub repository, but we did not change the Helm repository. So the Helm repository will stay the same, and it will be called Loki. So you will basically have an upgrade from the single binary, because I think that's what the original Loki one was about. And we will deprecate the Loki SSD one. So there will be only Loki. And the distributor one will be mostly community driven, because we feel the scalable version is the one you should be using. Because it's easier to maintain and fairly scalable. I don't know if anybody hits the scale to run the microservice version. Yeah.
Another question, because I looked at it yesterday, and there's also the Loki stack Helm chart. Is the idea also to update that with the newest version, or should we leave that community driven?
Yeah, I think so. I mean, that's a funny one, right? Because it does deploy, if I'm not mistaken, Grafana and certain other things. So I'm not really sure. What we can do is we can switch the Loki bit of it to our version. I think that's what we should be doing if we want to support it, but it should also be community driven.
Okay.
So Carson, I tossed a link in the community call notes. That's the right directory. And then to, I guess, Howdy's question, people should be using the Loki directory within there specifically.
Oh, yes, yeah. The other ones are actually empty. Like if you click on it, you will see that they are actually they have a big deprecation node.
All right, great.
So that actually answers the question for the Loki stack as well, I guess.
Yeah, this has been added when the repos first moved out of the Loki, as when the Helm chart moved out of the Loki directory.
Yeah, we should do the same on the repository for Grafana Helm charts.
Yeah.
That's it from myself. I think we can. Yeah, I don't know ETA. I think it would kind of correlate with the Loki 2.7. I would imagine.
Cool. Thanks, Kashin. Yeah. Does anyone have any questions about the Helm chart? We have 13 minutes left. Probably. Yeah, if you don't have any questions, then we can go on to any open Q&A. If anyone has any question in general. And also one thing I think I didn't say it correctly at the beginning is like about the timing. So yeah, I think we changed it from US time zone to EU, but it will be alternate. So for example, next time it will be US again, and then next time after it will be EU. So we're alternating between the time zones. Yeah, I mean, we'll keep update the calendar. So subscribe to the calendar if anything changes, so you'll be notified. So I just wanna post it there. Cool. Anyone have any questions, folks? All right. If nothing else, then we can wrap it up. Thanks everyone for joining.
Thanks for running it, Kavi.
Yeah,
Yeah,
Kavi,
no
thanks
worries.
for organizing and getting us set up with multi-time zones. Appreciate that.
Yeah, no worries. Yeah, I think thanks, folks. Thanks everyone for joining, and see you next time. Then, take care.
Yep. Thank
Everybody.
you. Bye.
Bye.
Bye.